What is going on, guys? Welcome to the second Raspberry Pi simulation focusing on GPIO. This time we will be playing with Python and Node to operate components such as LEDs and BME280 sensor. You need to have these components as well as the software installed on the Pi before proceeding. But just a heads up, never run any code when disconnecting the jumper wires on the Pi or it might cause short circuit. Now set up your Pi with the peripherals as seen here and switch it on. Open the terminal window and write out the commands to show the GPIO pins. Then open the phony in your Pi and at the same time test the red LED with the 3.3V GPIO. Connect the LED with a resistor to ground and pin 7. Set a coding on Python to make the LED blink for every 0.5 seconds and execute it. Then connect a push button to a ground and pin 3 as shown. Then write a Python coding to print this message when the button is pushed. Write another Python coding to print the message LED on when the button is pressed and LED off when the button is released. You can also control the delay period for the LED to turn up when the button is pressed or also to delay the LED to switch off after pressing the button. To make a traffic light model, set up a buzzer, connect it to ground and GPIO 11. Write and execute this Python code and the buzzer will start to click in an interval of 0.5 seconds. Connect a yellow and green LED as shown here. Write out a Python code to simulate a traffic light sequence on 3 LEDs, push button, and buzzer. To use the BME280 sensor, connect to the Pi's ground, 3.3V, SCL, and SDA pins. Enable the I2 kernel driver and increase the baud rate from 100 kHz to 400. Restart and add the Raspberry Pi user into the I2C group. Make sure the BME280 is communicating with the Pi properly, which can be done using the Pi's Linux terminal. The BME280 sensor can display the ID, timestamp, temperature, pressure, and humidity data separately or as a single string. Here's the process of writing the code to display the info separately. And here's a single string to display all the required information that the BME280 sensor can display. So that is one way to connect the LEDs and sensors with the Python to the Pi. Let us explore the other way here, which is using the Node. Boot up the Node and key in the Pi's IP address on the Chromium browser to display the Node interface. Connect a red LED and a resistor to pin 11 and ground. Inside the Node drag pin node, set it at pin 1 and name it as red LED. Drag in 2 inject nodes and change both payload as number, one of it as 1 named on and the other as 0 named off. Connect the 2 inject nodes to the red LED and deploy to test the on-off switches on the LED. Then head back to the Node and drag an msg.payload debug load and connect the on-off nodes to it. Deploy the entire flow and press the debug button to display the debugging message as shown here. Replace the on-off nodes with the Pi GPIO pin in node. Set it at pin 7, select pull up on resistor and name it as button. Join the button to both of these, deploy, and the LED should be lit. Now test the push button to switch off and on the LED. Another way to do this is by using a switch function node. Maybe as if input is 1. Set a comparison operator as 1 and otherwise to produce 2 outputs on the node. Connect button to the switch function and add 2 change functions, naming it change to 0 numbered 0 and change to 1 numbered 1. Deploy and the switch should be able to on and off the LED. Now connect the BME280 to the breadboard and the Pi as shown. Open the Node console and connect to the local host using Chromium. Insert an inject node, a BME280 output, and msg.payload debug node. Join them all, press deploy, and inject the timestamp. View the sidebar and you can see the temperature, humidity, and pressure. To modify the flow to display only the temperature, add a change function and set the msg.payload to msg.payload.temperature_C. connect them all, deploy and inject. The temperature reading will be shown here on the debug message on the right. Replace the MSG.payload with a chart node and label it as temperature in C. Edit the payload of the inject node as a number starting from 1 with interval of 5 seconds. Deploy, inject, and the temperature graph will be visible on a new tab. Notice how the graph will plot out the temperature of the surroundings over the next 5 seconds. And lastly, this graph can also be accessed with a smartphone as shown here by entering the IP address. So that is all from us. Thank you all for watching.